Hello, this is a brief video showing some of the features of my LED matrix display. I've designed and built a custom PCB and written the software which runs on a Pi Pico W and uses MQTT to receive the data it displays from a Home Assistant installation running on my network. To keep things interesting, there's an FPGA driving the display. As you can see, the screen cycles through various displays showing the time and date, temperature information from various sensors scattered throughout the house, the current weather, a weather forecast, some information from upcoming calendar appointments, and since we get the bus often, it shows the times of the next few buses. Here's a picture of the board I've designed in KiCad and had manufactured by JLC PCB. The board is dominated by the Pi Pico W. Other key parts are the DS3231 real-time clock IC and an FPGA in the form of an ICE40 UP5K, which drives the LED matrix. Whilst you can drive this kind of LED matrix, called a Hub 75 display, directly from a Pi Pico, I found the screen would suffer from occasional flickering, even though I was using a dedicated core in the RP2040 and PIO mode to drive it. If you are happy with this kind of flickering on heavy network activity, you can build the firmware and the board without support for this FPGA. There's also a buzzer which can sound when a notification is shown and at other times if desired. Here's what the display looks and sounds like when it gets a notification message over MQTT. In terms of software, it's built on top of FreeRTOS and makes use of the MQTT stack provided. CJSON is used for parsing and forming up JSON blobs. The graphics routines were written by me. I'm quite pleased with the compact font I designed, shown on the calendar screen and other places. One other feature I quite like is that the display will show the title, artist and album name of the currently playing music track, as you can see now. We have a motion sensor in the porch which is used for turning the porch light on and off. It will also generate a notification on our phones, which is useful if we're in the garden or whatever. Just for completeness, the display will indicate movement in the porch using a little icon in the corner of the screen, since showing a full on notification seems like overkill. Here it is, flashing away now. Configuring this thing is done through Home Assistant by creating automations, or one big automation if you prefer to set it up like that, which feed the display data over MQTT. Eventually I hope to come up with an easy to use blueprint, but for now it's not that hard if you are familiar with HA templates to get this going using the Home Assistant user interface. For instance, here's what the media player glue looks like. You can see it's just a MQTT publish service call with a specially formed template. The trigger for this publish call is on the content ID attribute for the media player, as well as the media player being turned on or off. The most complicated point of integration is the weather information, which includes the temperature sensor data, the current weather state and the forecast. I'm using Open Weather Map, but I don't think that matters a great deal. The board I designed has a pin header for the I2C bus. For fun, the software supports hooking up a BME 680 temperature, pressure and humidity and gas sensor breakout board. I haven't done anything with the gas sensor since it requires a closed source library from Bosch, but the other three sensors are exposed, and comparing the data generated to my other off-the-shelf sensors I have in the house, seems to be extremely accurate. If you don't want to use a BME 68 breakout board, you don't have to. In this case, the temperature available out of the DS3231 will be exposed instead. Talking of exposed things, the firmware supports MQTT auto discovery. Send it a message on a particular topic and it will send out messages to Home Assistant to instruct it to create a device for controlling and monitoring the display. The LED matrix panel itself presents as a dimmable light, so the panel can be dimmed or turned on or off as a light. This is pretty cool. I use it with a couple of presence sensors in the living room to turn off the screen and save a little electricity when the lounge has no one in it. In terms of actual good old-fashioned hardware in the meaning of the word before computers came along, I made a wooden backpace for my Hub 75 display, which was purchased from the Pi Hut. I CNC'd it on my homemade CNC machine and everything. I made it in wood to give the panel some weight so it would stand upright without falling forwards, but I'm sure there are other solutions. I also have a back case that will hold the electronics CAD'd up, but need to make some changes to it before I print it on my 3D printer. This will then finish off the hardware side. Power, by the way, is supplied by a 5-volt barrel plug. At some point, the Hub 75 panel fell off the mantelpiece, and at least one pixel was lost out of a corner. I need to buy a new one and possibly look at a diffuser while I'm at it. This project is currently split over 3 repos on GitHub. The PCB design, consisting of the KiCad files, Gerbers and bill of materials, the PiCodeW firmware source code, and the Hub 75 controller code, which is written in Verilog. There's of course a whole load of things that could be added or improved. I have a few of my own feature ideas and improvements which are probably overdue, like SSL support for the MQTT connection, but I'm keen to hear what other folks have in mind, and more generally, what do you think of my little creation here? I'm personally pretty pleased with it and find it useful. I'll end by showing you another little feature I added just before last Christmas. Thank you for watching.